This video, I'm going to be simplifying radicals. I'm going to continue on with previous videos. I am now on number 4, which is the square root of 1800. I'm going to simplify this completely. I'm going to still be using the same chart that I had in previous videos, the perfect squares, cubes, fourths, and fifths. So I'm going to the square root of 1800, and because this number is much larger than the largest perfect square that I have written on my list, I have to definitely make sure that I simplify all of my radicals. So I start with 225. I know hopefully it's going to be the square root times square root. So if I use my calculator, I'm still going to do 1800, and I'm going to divide it by the biggest perfect square that I have listed, which is 225, which gives me a whole number. So I know it's going to be 1800, 225, and 8. So I can put my 225 and my 8. So I know that, again, from the list, the square root of 225 is 15 times, and it'll be the square root of 8. Now, before I finish, I have to make sure that this 8 cannot be simplified further. The 8 can be divided by the 4, because the 4 is the first number that's smaller than 8. So I do 8 divided by 4, which works again. So that means I have to actually continue that. This square root of 8 will actually become the square root of 4 times the square root of 2, which the square root of 4 is 2 times the square root of 2. Now, the reason I did this is because if I were to type in the square root of 1800, I get a decimal. If I were to type in it was 15 square root of 8, I get the same decimal. But we don't know if it's completely simplified, which is what we're trying to do, completely simplify. So now that the 2, the radicand of 2, can only be divided by the 1, I know that this is simplified completely. So I just have to put it all together. To put it all together, I had actually 2 coefficients. I have a 15 from the first part, but now I have a 2 from the second part. Now all of my coefficients that come out, I actually multiply together, and then I multiply it by the final radical. So the final radical was the square root of 2. So our final answer should be 30 square root of 2. Now I still have these values in here, and I have the same decimal. Now I want to check 30 square root of 2. 30 square root of 2 actually gives us the exact same decimal, so now it is simplified completely because that square root of 2 cannot be simplified further. So this is our final answer. So again, because 225 was nowhere near the same size as 1800, I knew that I have to check more values for my radicals that I end up getting. This next one is the fourth root of 405. So we look at the perfect fourths column and we divide by those numbers. So 405 can first be divided by 81. So 405 divided by 81, because that's the first number that is smaller, and it works automatically. So it's 405, 81, and 5. So this is equal to the fourth root of a number times the fourth root of a number. The fourth root, the numbers were 81 and 5. The fourth root of 81 from the chart went back to 3 times the fourth root of 5. The fourth root of 5 cannot be simplified further because if you look back at the perfect fourths column, you see that the number 1 is the biggest number that could potentially go into it, and if it's just the 1, that means you can't simplify it further. So this answer is 3 fourth root of 5. Notice that when I put my 4, it is inside that nook. So 3 fourth root of 5. And I will show you how to put that into your calculator. So I want to go to this math button, the math button, and I want the fourth root. Now on here I have a cubed root, but here, number 5, it has an x inside your root. That means I can change my root. So I'm going to go down to this one. Now I'm going to go change this part, because right now it says answer because it was from my last answer. I want to change that number to a 4. I don't delete it. I don't clear it. I just type in the number 4. That's my 4th root. Then I want to type in 405 because that was my first original problem. I get this decimal. And I go back and do the same thing. First I'm going to type in the number 3. Then I'm going to go to the math button. Go down to the xth root. Notice that it has the 3 in front of it now, so I have to be very careful about this. I want this number to be a 3. And then I want to change the index to be a 4. So I had to actually change that one, so be careful about that. Then I want to put the 5 in there, press enter, and I get the same decimal. So if you want to, you can actually put 3 parentheses, then go to your math button down here, and now it actually has you can put the 4, and then you can put your 5 in here. And then I press over, and then I can close my parentheses, and I get the same value. Older calculators might look a little different. I can show you on an older calculator. At a little bit later. I will show you on an older calculator a little bit later. This next problem is the 5th root of 8,192. So for the 5th root, I'm going to do the same thing. I'm going to look at the perfect fifths. I have 1,024 as my largest number. I'm going to check. 8192 divided by 1,024 does work. So it's 1,024 and 8. So this is the 5th root of 1,024 times the 5th root of 8. Those are my two numbers. The 5th root of 1,024 was the 4, going back to the row, times the 5th root of 8. And going back to the perfect fifths, 8, the biggest number that we can check. 32 is too large, so 1 is the only possible number that could work, and that means that the 8 is as far as it can go. So our final answer is 4 times the 5th root of 8. And again, you can check that in your calculator using that math button. On the next one, we go back to the square root of 384 because there's no index in there, so that means that's an automatic 2. So we do 384 divided by the first number we check is 225. That's a decimal. 384 divided by 196. Decimal. 384 divided by 169, decimal. 384 divided by 144, decimal. And I'm just gonna keep going up the list. 384 divided by, since I did 144, I know it's gonna be 121 now. 384 divided by 100, I know won't work. 384 divided by 81. So if there's any numbers that you know definitely cannot work, like the 100, I could have actually skipped that one, just because I know that won't work. 384 divided by 64 works. 384 divided by 64 will work, so that's 64 and 6. So the reason you have to go all the way up, because sometimes you could have multiple numbers that work, but if they're too small, then you'd have to simplify again. So this is square root times square root, and again, I don't have a number in the index because it's still a square. This was 64 times 6. Square root of 64 is 8 times the square root of 6. 6 can be still checked with the 4 and the 1, but 6 divided by 4 would still give us a decimal, and then 6 divided by 1 would work. So it's just the 1. That means that this will be our answer. So this is 8 square root of 6 is our final answer. This next one, number 8, is the 5th root of 32. Now, if you look at the perfect fifths column, 32 is actually already a number there. So the 5th root of 32 is already possible. It's just 2. So our answer for this is just equal to 2. We don't even have to divide by anything because it's already a number in there. So that's automatically your answer. So if you see the number already in the chart, it's already a perfect answer. So you can just find the original column it came from. This last one on here, if you look, it already has a coefficient, so we don't do anything with the coefficient. We just know that in the end, we're going to have to multiply all of our coefficients together. So just ignore that until the very end. So we know that this is going to be -6 times something. So we have to deal with the square root of 48. So that is not a sixth root, that is a -6 times because it's not in the index. So we do the 48 divided by, so the first number that is big enough to work would be the 36 because 49 is too large. So 48 divided by 36, 48 divided by, again, if you know 25 won't work, you can skip it. 48 divided by 16 does work. If we had started from somewhere else, so 48 divided by 4 also works. So if we had started from the top of the list and gone down, which is not what you're supposed to do, 4 would have worked as well, but you would have had to have simplified even more. So that's why we look for the largest number that goes into it. So that's why we focused on this 16 instead of starting with the 4. So again, it was 48 divided by 16 was that first one. So it's 16 times 3. So it's the square root of 16 times the square root of 3. So we still have this -6 as a coefficient. The square root of 16 is 4. Then we have the square root of 3. And 3 can only be divided by the 1 in the perfect square row, in the perfect square column. So that means that this cannot be simplified further. So all we have to do is just multiply these now. -6 times 4 is -24. Then we have the square root of 3. So this will be our final answer. And again, you can always check this back into your calculator by doing, it was -6 square root of 48. So -6 square root of 48. We get this decimal. And then we had, as our answer, we had -24 square root of 3. It's the same answer. So we know that we simplified it. And because the square root of 3 can't be simplified further, we know that this is our final answer. So if we want to use an older calculator to check the square roots, we can. So I'm going to show the square roots on an older calculator. Actually, I'm going to show the fifth roots right here to make sure you know how to use it in an older calculator. This is a slightly older one, just the software is older. So I still want to go to the math button for the fifth root. I want this one. But do you notice that it now has the answer here? This one is a little different. So instead of it being up in where the X is, I have to be very careful about this. I have to say that I want the fifth root, 5 first. Then I press the math button. Then I go down to this one. Now this is actually saying the fifth root of 8192. 8192. Actually, I don't have a parenthesis, so I don't close it. And I get that 6 and 600ths. Now I want to check my answer of 4. So I do 4 parentheses. Then I have to put the 5 for the fifth root. Go to the math button. Come down to the xth root. And I type in 8. Now this parenthesis, I do want to close it because this is coming from this parenthesis. And I get the same value. So on the newer calculators, I'm going to make sure I have the same decimal. So I go to 5 math root. That turns it into the fifth root of 8192. And I still get that 6 and 600ths, which is the same as what I had here. So newer calculators will actually put it into the index. Older calculators, it won't put it into the index itself, but this becomes the index. So if you have a coefficient, you have to make sure your coefficient is on the outside of the parentheses on these older calculators.